Welcome to section 6.1, Solving Trigonometric Equations. Solving trigonometric equations is a key part of applying what you've learned about trig functions. Just like in algebra, we use the properties of equality to isolate the variable and find the solution. The difference is that here, the variable usually represents an angle, and the equations involve functions like sine, cosine, or tangent. The goal is to find all possible angle values, usually within a specific interval like 0 degrees to 360 degrees or 0 to 2 pi, that make the equation true. This section has one objective: solve trigonometric equations using the properties of equality. So what are the properties of equality? Well, the properties of equality allow us to perform the same operation on both sides of an equation without changing its truth. These include addition-subtraction property, where you can add or subtract the same value from both sides; the multiplication-division property, where you can multiply or divide both sides by the same non-zero value; the substitution property, so this is replacing a value or expression with something equal to it; and the square root property, which states if x squared equals a, then x equals plus or minus the square root of a, when solving equations involving squared trig functions. So I've provided here 4 steps for solving trigonometric equations using properties of equality. The first step is to isolate the trigonometric function. So we can use addition, subtraction, multiplication, or division to get the trig function by itself. 2, we'll use the unit circle or known values to find angle solutions. So if you get something like sine x equals a half, you can use your knowledge of the unit circle to find angles that have that sine value. Step 3, include all possible solutions within the given interval. So remember, trig functions are periodic, so many angles can have the same sine, cosine, or tangent value. So we want to make sure to include all relevant solutions. And we can use reference angles, adding and subtracting to pi or pi to help us find those other possible solutions. And then 4, if needed, solve using inverse trig functions to find an angle when given a decimal. So let's walk through some problems together. First, let's review how to solve equations. So we have our algebraic equation here. 6x minus 9 equals 2x minus 5. So to get x by itself, what we can do is get all the terms that have x on one side and then all the terms that don't have x on the other side. So let's subtract 2x on both sides, and then we can add 9 on both sides. So 6 minus 2 will get us 4x. Negative 9 plus 9 is 0. 2x minus 2x is 0. And then negative 5 plus 9 is 4. We then can divide both sides by 4, which then simplifies to x equals 1. All right. Next, we're asked to solve for x if x is between 0 and 360 degrees inclusive. So our equation is 2 cosine x minus 1 equals 0. And we want to get the trig function by itself. We want to isolate cosine x. So let's add 1 to both sides first. And that'll get us 2 cosine x equals 1. And then we can divide both sides by 2. That will leave us with cosine x equals 1/2. So we want all of the x values where cosine equals 1/2. And we can use our unit circles to help us. and we want the angle measurements between 0 and 360 degrees. Since the cosine here is positive, using our acronym, all students take calculus, we know that cosine is positive in the first and fourth quadrants. So we'll look for the angles in those two quadrants that have a cosine of 1/2. Okay? And so using our unit circle here, that would be 60 degrees and it would be 300. So x equals 60 degrees or 300 degrees. Right, next we're asked to find all values of x for which 2 sine x plus the square root of 3 equals 0, where x is between 0 degrees and 360 degrees. So let's write our equation. 2 sine x plus the square root of 3 equals 0. We want to isolate the trig function. So we'll have 2 sine x equals negative square root 3. Then we will divide both sides by 2, which will get us x sine x equals negative square root 3 divided by 2. Okay, so similar to the last problem, we want the angle measures where our sine is negative square root 3 over 2. So since sine here is negative, using our acronyms, all students take calculus. Sine is negative in the third quadrant and in the fourth quadrant. So those will be the two quadrants we will be looking at. So using our unit circle, here I see that 240 degrees and 300 are the two angle measures where our sine value is negative square root 3 over 2. All right. Here we're asked to solve for x. Again, x is between 0 and 360 degrees. This is similar to our last problem where we have 3 cosine x minus 5 equals 0, and we need to isolate our trig function. So we'll add 5 to both sides. Then we'll divide both sides by 3. Okay, so we need to find the angle measure whose cosine value is 5 over 3. But wait, 5 over 3 is 1 2/3. And all of the values on the unit circle are between 0 and 1. And this value is greater than 1. So there actually won't be any angle measurement that has this value on the unit circle. So there's no solution because cosine x cannot be greater than 1. All right, for this next problem, we have the equation 2 cosine x minus 3 equals 5 cosine x minus 2. Okay? And so, just like in all of the other problems, we want to isolate the cosine function. Okay? So let's get all of the terms that contain cosine on one side, and then all of the terms that don't have the cosine function on the other side. So let's subtract 5 cosine x on both sides. And then we'll add 3 on both sides. That way we move the cosine terms to the left and the constants to the right. So this will give us 3 cosine x equals 1. So cosine x equals negative 1/3. Okay. Now, negative 1/3 is not one of the standard values on our unit circle. So that means we're going to have to use another method to find the angle measurements whose cosine is negative 1/3. Okay. Since cosine here is negative, using our acronym, all students take calculus, we know our angle measurements are going to be in quadrant 2 and in quadrant 3, okay, because that's where cosine is negative. So let's take the inverse of cosine to find our reference angle. So we'll take the inverse of cosine of 1/3. And when we substitute this into our calculator, rounded to 1 decimal, we'll get 70.5 degrees. Okay, so this is our reference angle. Okay, this angle measurement is in quadrant 1, and we can use this reference angle to find the two angle measurements in quadrant 2 and 3 that will solve this problem. Okay. So, since we want an angle measurement in quadrant 2, we will take 180 degrees and subtract our reference angle, which will get us 109.5. And then for quadrant 3, we will then add 70.5 to get 250.5. Therefore, x are the measurements 109.5 degrees and 250.5 degrees. Awesome. All right, so now let's review a more complex algebraic equation. So we have 2x squared plus 3x equals negative 1, and we're asked to solve for x. So we have a square here, and so that should signify that we are working with a quadratic equation. So I'm going to add 1 to both sides so that I can get my quadratic equation set equal to 0. So then I'm going to factor this quadratic, and I will get 2x plus 1 and x plus 1. I'll then use the zero product property to set each factor equal to 0. And then I will solve for x. So in the first one here, I'll subtract 1 on both sides and then divide both sides by 2. And then the second one, I'm just subtracting 1 on both sides. So x equals negative 1/2 and negative 1. All right. Okay. So now let's apply that concept to a quadratic function involving trig functions. So here we're asked to solve for t. All right. So we have 2 cosine squared t plus 3 cosine t equals negative 1. So let's add 1 to both sides and set the quadratic equal to 0. Okay. Now, when you have a lot of trig functions like this problem where you have cosine squared and cosine, it can look a little bit confusing when trying to factor this equation. So to help us out, we're going to let u equal cosine t. That way we can write this equation in terms of u. And this just allows us to see the quadratic better without all of the letters involved. Okay, so now we can factor this equation. And when we do so, we will get 2u plus 1 and u plus 1. So now we can set each factor equal to 0. So we'll have 2u equals negative 1, u equals negative 1/2. Then we have u plus 1 equals 0, so u equals negative 1. So we are trying to, well, before we try to find our solutions, we now need to back substitute. So we changed cosine t to u, so now we want to convert it back to cosine t. So we'll have cosine t equals negative 1/2 and cosine t equals negative 1. Okay, so for both of these values, cosine is negative. And so cosine is negative in quadrants 2 and 3. So we want our values of t whose cosine is negative 1/2. And since our interval is given in radians, we want the radian measure for our angle. So looking at our unit circle here, trying to identify where negative 1 is and negative 1/2 is for the cosine value. We have pi, because that's where cosine is negative 1. And then for negative 1/2, we have 2 pi over 3 in quadrant 2. And we have 4 pi over 3 in quadrant 3. So t is 2 pi over 3 or pi or 4 pi over 3. All three values will make our equation true. Awesome. Okay, number 8. So here we're asked to solve for t again, where t is between 0 and 2 pi. Okay, so we want our angle measurement in terms of pi. So that can be written as a decimal or with the symbol pi. And our equation is 2 sine squared t minus sine t minus 2 equals 0. So to help us out to see if we can factor this, since it's already in quadratic form set equal to 0, we're going to let u equal sine t. So we'll have 2u squared minus u minus 2 equals 0. Okay, so let's see if we can factor this. Let's see. So we'll have 2 values. So we know this is 2 in u and then 2. And I want a negative 1. So if I put 2 here and 1, that will cancel out to 0. If I switch it and I put 1 and 2, then that would make 4 and 1. So there's actually no 2 factors that I can use. So this quadratic is not factorable. So that means I need to use another method. And the other method that I can use is the quadratic formula. Okay. So the quadratic formula says x, let me write it out for you, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So our x here is u. It's technically sine, but we'll convert it back towards the end. And our b here is -1. So I got that from my quadratic equation where a is 2, b is -1, and c is -2. So having these values, I can now substitute them into the quadratic equation. So our b is -1. So we'll have -1 squared minus 4ac all over 2a. So simplifying this, we'll have 1 plus or minus the square root of 1 plus 16 over 4. So that's 1 plus or minus the square root of 17 over 4. Okay. So now let's substitute sine back in for u. So that means sine of t will equal 1 plus the square root of 17 over 4 and 1 minus the square root of 17 over 4. If we enter these ratios into our calculator, rounded to 4 decimal places, we'll get the following values. Okay. Now, this first value we know we won't be using because sine of t cannot be greater than 1. So we'll only be using this second value to help us find the values of t that make our equation true. So we'll use this as our reference angle. So let's find the inverse of sine of 0.7807, and this will get us 0.8959 rounded to 4 decimal places. Okay. Now, because our sign is negative, okay, because the value is negative, we know, according to All Students Take Calculus, we'll be looking for angle measures in quadrant 3 and in quadrant 4. So, in quadrant 3, we will take pi plus 0.8959, which equals 4.04. Then in quadrant 4, we'll take 2 pi minus 0.8959, which equals 5.39. Okay, and so t are, or t can be these two values, 4.04 or 5.39. Both values make our equation true. Awesome. Well, that concludes section 6.1.